Hey guys, welcome back to my YouTube channel. So last class we have discussed majorly on the density of states and the multiplication with the Fermi level. So that we have came to understand about the beautiful concept of how much quantity of free electron and free holes are available in an semiconductor. So that thing I hope that is very goodly we have gone through it. So even if you guys have any doubts, please feel free to ping in the comment section. So let's find. Last class we see about this graph, right? So this is the percentage of area where there is a free electron concentration, and this is the percentage of area where there is a free holes concentration. So let's now try to find out the how much is the quantity, say physically, how much like in the terms of a numerical value, how the values will be there. So let's derive an equation formula so that we will be able to get it. So this one we discussed, right, from the density of states in the free electron concentration will be from EC to infinity, which is multiplication of density of states into Fermi level over the dE, right? So which is will be centimeter per minus 3. So which is the cubic free electron concentration. So we are no need to worry about the calculation. So these things will be, this is a 1.5 to 2.5 page of a calculation will go through. So we could directly use the formula, which is nothing but NC e power minus EC minus EF, okay, divided by KT, centimeter minus 3. So this NC, which is nothing but the effective density of states. So NC is the effective density of states. So this is one of the constant value. So effective density of state. So this is effective density of states in conduction band, CB. Okay, if you guys need to know how these value come, please go over the Google's. There is many kind of papers and books are available where you can see about how this calculation came into picture. But that is not needed, so you guys can skip it. The value of NC, which will be equal to 4.82 into 10 to the power 15 with the multiplication. It also depends on some quantity, that is mass of an n electron divided by the effective mass carrier concentration, which is 3 by 2. So which is centimeter per minus 3. So this is some kind of thing you can have it. So generally if they giving in a question, these values will be given. The NC value will be given. So that is no need to worry about this. So the Mn is nothing but effective mass of electron, and M is the free mass electron. So free electron mass. So Mn is effective mass, but the M which is nothing but the free electron mass. So there is lot of difference between their effective mass and free electron. The effective mass we have already find out how that is directly proportional to the curvature that we have already see in the wave vector or the space vector with the momentum conversion. So if you guys have missed that lecture, please go and watch my lecture. I think it's in 7th or 8th lecture, I think. So that will be helpful for you guys to understand. So this is how the free electron concentration can be obtained here. I hope this is understood for you guys. So let's find the free holes concentration. So P, so which will be equal to minus infinity to EV, which is a max electron, which is with the density of states over 1 minus f of e. So why this is 1 minus f of e is the f of e is the probability of presence of electron. The 1 minus f of e is the probability of presence of holes. So that's why we are making this one. So then this will be equal to nv e power minus ef minus ev divided by kt with cubic centimeter. Okay. So nv is nothing but effective density of states in valence band. So this is nothing but the effective density of states. So effective is the term that in the particular scenario at particular energy level with some temperature reference they will say. So that's why this effective will come. So effective density of states. Effective density of states in the valence band. Okay. Here also NV also have some terms. So that will be written as NV, which is equal to 4.82 into 10 power 15, the same value, MPT divided by M whole power 3 by 2. Okay, so this thing. So MP is the effective mass of holes and M is the free electron mass. So the base reference is electron only. So if some numerical comes, then that is the thing there. So in case of an intrinsic semiconductor, so let's take an understanding with the intrinsic semiconductor. We know that in intrinsic semiconductor, N and P which will be always equal. So if we compare this one, we need to obtain some kind of formula. We know the N and we also know the P. So if we substitute both one, like E into EC minus EF divided by KT. As this is intrinsic, right? So we can make it as EFI, okay, divided by KT, which is equal to NV e power minus EFI minus EV divided by KT. Okay, so let's bring this term here and this term here, like exponential term to one side and other term to one side. So NC divided by NV, which will be equal to e power minus EFI minus EV divided by KT divided by e power minus EC minus EFI divided by KT. Okay, so this is exponential, right? So we can bring this term to above so that we can directly subtract the terms. So if we bring this term to above, it will become positive. So let's take minus as common, full common. So this term will be as it is EFI minus EV. Once this term comes above, it will be positive. But if we took the minus outside, then that will become EC minus EFI. Okay, divided by KT. The EFI and this term, these two terms can be cancelled. Okay, then the minus sign will also be taken out into subtraction. Sorry, I missed one thing. This will become plus. Okay, so let's add both the term and subtract the rest of term, like to group this together. So if we take it, this will be EFI minus EC minus EV divided by KT. Okay, so let's bring this E into this side. So when E is taken this side, or if we take ln, E will be getting cancelled. So if we take ln, then it will be ln NC divided by NV. Okay, this E will be cancelled. So which will be equal to 2 EFI. So let's bring this minus inside. Then this will be EC plus EV divided by KT. Okay, so this term together we can represent this as a thing. The KT can be bring to that side. So KT ln NC NV. So which is equal to 2 EFI plus EC plus EV. Okay, let's go on to the next page. Let me rewrite it. So KT ln NC divided by NV, which will be equal to minus 2 EFI plus EC plus EV. Okay, here how we can write the thing is that this is an hint. So EC plus EV divided by 2 will be the mid level, right? So mid level thing we know that, so we can divide this by 2. So if we divide this by 2 and bring this term, let's bring this term to this side and this term to another one separate side. So let's bring this here and this that side. Okay, so this will become positive, right? So EFI, let's also divide it by 2. So this will be EC by EC plus EV divided by 2 plus KT divided by, this will become minus, right? So this is minus. So minus KT divided by 2 ln of NC divided by NV. Okay, so this will be understood. So this is the mid level. So we can even write this as the EFI, which will be equal to E mid minus KT divided by 2 ln NC by NV. So here we are coming to an observation that the EFI, the intrinsic Fermi level, will not be equal to mid level. There is some kind of subtraction is also coming together. So we blindly assume many times, right? So if it is EV and this is EC, sorry, this is EV and above is EC, then the middle center one is we always consider as a EFI. But now we are coming to think that this is EVEC then the EFI, which will be slightly lower than the E mid. So E mid will be here. So some kind of thing it will come here. But EFI will be slightly lower than this. That the lowering amount is this one, KT divided by 2 ln NC by NV. So this is one of the important physical significance we have to note it. So we now able to see that the mid level is not equal to EFI in the intrinsic semiconductor. So this is tilted or subtracted by a small quantity that is equal to KT by 2 ln NC by NV. So these all are, you may guys note that these all are simple terms, but this is a very important term. Even in if you guys, if some kind of interviewer need to twist you, then they may ask what is the how much amount or how the difference. If you are going for any kind of technical interviews in like for higher studies, then these kind of questions we can expect in microelectronics and those kind of things we may expect. So please watch the video again carefully. If you ask any doubt, please post in the comment section. Like, share and subscribe the channel so that you guys will be notified for all my videos that are uploaded here. Stay tuned for next lecture. We will be starting the observation for P-type, N-type and everything. Thank you.